Can you use quadratics when multiplying and dividing these fractions?
Of course you can.
How?
The same rules apply. First, you factor.
Then you simplify.
Let's start. X squared minus 6x minus 16 over x squared minus 16x plus 64 times x minus 8 over x squared plus 5x plus 6.
Using the laws of factoring, you factor x squared minus 6x minus 16 into x plus 2 times x minus 8.
X squared minus 16x plus 64 can be factored into x minus 8 times x minus 8.
Finally, x squared plus 5x plus 6 factors into x plus 2 times x times 3.
Now you can eliminate common factors. X plus 2 crosses out with x plus 2, and x minus 8 crosses out with x minus 8 twice. So your final answer is 1 over x plus 3.
So, what happens when you divide these expressions?
Whenever you see division, try to make the expression into multiplication.
Let me explain. When there is a division sign,
Divide?
when you see a division sign, you must use the multiplicative reciprocal of the following value.
Here's an example. 6c over 5d divided by 8a over 15cd squared.
The first thing you do is make 8a over 15cd squared, 15cd squared over 8a.
Then you use the same steps as multiplying.
Your answer should be 9c squared d over 4a.
So remember the three main steps. 1. Factor the numerator and denominator. 2. Eliminate common factors. And 3. Simplify.
So what do you remember from middle school about adding and subtracting fractions?
Well, I remember that in order to add two fractions, the denominator had to be the same.
That's right, Dan. An example of this would be 1/5 plus 2/5.
Well, since the denominators are equal, all you have to do is add 1 and 2 to get an answer of 3/5.
Now, let's say we have 2/3 and 1/6. How do we solve that?
But how do we get the denominators to be equal?
It's simple, Dan. Don't frown. All you need to do is find the least common denominator of 2/3 and 1/6, which is 6.
So based on that logic, you should multiply the denominator 3 by 2, giving you 6. And the numerator 2 should be multiplied by 2. As well, because it keeps the fraction equivalent to its simplified form, giving you 4/6 plus 1/6, which is 5/6.
Let's move on to putting variables into fractions and then simplifying them. So, for example, solve x plus 1 over x to the second minus 1.
Ooh, I know how.
Go ahead, Dan.
We can simplify x squared minus 1 into x plus 1 and x minus 1, right?
Indeed. Then you would have to simplify that as well. Since you have an x plus 1 on the top and bottom of the fraction, you can cross out both of them and substitute the missing numerator with a 1.
Right, so our final answer would turn out to be 1 divided by x minus 1.
Alright, so we're going to make this a pretty difficult question, so get ready. The expression 6 divided by y minus 5 minus y plus 5 divided by y squared minus 25. Before you start this, it would be smart to simplify the binomial y squared minus 25.
Wait, hold on. What is going on? Please, make this stop.
Dan, don't fear. First, you should simplify the term that Safir described into y plus 5 and y minus 5. Then, because there is already a y plus 5 on top, you can cross out both y plus 5s and replace them with a 1.
Then you would have 6 minus 1 on top, and y minus 5 and y minus 5 as the denominators. Because they are common denominators, do not change them. Simply do 6 minus 1, which is 5, and put the denominator on the bottom. Your answer should be 5 over y minus 5.
Alright folks, hold on to your hats because this one is going to get even more difficult than before. What is the sum of y minus 5 plus 3 over y plus 2?
Ooh, I know it this time.
Go ahead, Dan.
Y minus 5 is put over 1. Then, wait, David, how do you do that? How do you get the denominators to be equal?
Well, since the denominator of the other fraction is y plus 2, we should multiply the denominator of this equation by y plus 2. However, to abide by legal math rules, we must multiply the numerator by y plus 2. By FOILing, we should get y squared minus 3y minus 10 over y plus 2.
But wait, do not forget to add negative 10 by 3, because they are numerators. By doing this, you should get y squared minus 3y minus 7 over y plus 2.
Since this is our 15th minute, I, Safir Dean of Safir Academy, would like to thank Geico for their sponsorship. You know their slogan, so easy to save money, Sharkeisha could do it. Essentially, by following the basic rules of keeping fractions equivalent, you will be able to solve rational expressions that require you to add and subtract fractions.
I got this, guys. Now it's time I teach you how to simplify complex fractions. Now, of course, you guys know how to do this, right?
I don't think I remember this unit. Jackson?
Of course I know this. Safir, a little help?
I was cramming for an AP Euro exam. Go ahead, Dan. Lead us like Moses Mendelssohn.
Let's start with the rules. You have to start by multiplying all values by the least common denominator.
So, how would you simplify x over x plus 2 over 1 minus x over x plus 2?
Using the rules of the LCD, would the LCD be x plus 2?
Exactly, Jackson. You then multiply each part by x plus 2.
So you get
X over x plus 2 minus x.
Are we done?
not quite. We have to simplify. So the answer is x over 2.
As the Chief Financial Officer of Safir Academy, I would like to say something about one of our sponsors. Pepsi. The official drink of, oh, we don't have Coke. Is Pepsi okay? Now, it's time for a harder problem.
Oy vey.
So what's the problem?
1 over 3 minus 1 over x over 3 over x minus 1.
Would the LCD be 3?
No, it would be 3x, because the 3 wouldn't cancel out 1 over x. So your LCD is 3x.
Then we have to multiply all parts by 3x to get x minus 3 over 9 minus 3x.
Is there anything left to simplify?
Yes, you would have to factor the 9 minus 3x into 3 times 3 minus x.
Cross out x minus 3 and 3 minus x and get a negative 1 in the numerator and a 3 in the denominator.
Therefore, your answer will be negative 1 over 3.
Alright students, who wants to graduate? The first person to raise their hand, be called on, and answer this question correctly will receive an honorary diploma, which signifies that they have officially graduated from the Algebra 2 and Trigonometry midterm review session brought to you by the Safir Academy.
We would like to thank you for watching this production of Safir Academy. This broadcast was made in a bunker somewhere in Baghdad.
That's a sin. I won't ever slack up. Punk, you better back up.